Hi guys, I'm having a heck of a time with my software today. So if I seem a little off, it's that I'm really distracted by hiccups that I've had that you haven't seen. Okay, so persistent infections. The one that I want to talk about that's probably most familiar to you is the chronic latent state. So this is when, for example, in my situation, I had chickenpox as a kid and did not need to have a vaccine for that. In fact, there was no vaccine for that back then. Most of you have probably been inoculated against chickenpox. Well, essentially, chickenpox is part of a herpes, what we call the herpes zoster virus. And that chickenpox can lay latent, essentially in your nerves, and then it can become re uh, stimulated or activated, if you will, under the influence of various stimuli. So age, declining immunity, stress. It happened to me when I was in nursing school. I got shingles. I recently had another little patch of shingles, even though I was vaccinated, but the infection was so little. But essentially, that herpes zoster virus can become reactivated and cause shingles, which is way worse than chickenpox. So it's just a way that it's essentially managing to get by and reproduce itself. And in fact, once that you're starting to have the pustules and they break open, it's very, very infectious. Okay, so 20% of cancers are caused by what we call oncoviruses. Onco means cancer or cancer-causing viruses. And essentially, you probably have heard of this with human papillomavirus causes cervical cancer. So pretty big in the world of thinking about disease and cancer, of course. And now we have some vaccines against some of these viruses. So we see down here, so mammalian oncoviruses. I mentioned the first one, a particular herpes virus called Burkitt's lymphoma, hepatitis B virus. Of course, there's vaccines for that. And then lastly, a type of leukemia lymphoma. All right, let's talk about the second major topic this week. It's just a small little part of our chapter. And in fact, you want to look at chapter 17. There's some supplemental material there, just a couple pages. But prions are proteinaceous infectious particles. So this really just blew people's minds when during the late 1990s, there was an uptick of some diseases, a human version of a bovine disease, which we call mad cow's disease. And so it was like just shocking to think that there could be an infectious protein particle. There's no nucleic acid, it's simply a protein. These proteins are so stable that, like the normal things that you think about would kill them, like disinfectant, or you're boiling your water, or you're cooking your food, like very thoroughly, radiation, none of that kills these infectious particles. So still being investigated. Again, if you all decide to go into research, this might be something that you want to research. But essentially there's these long protein fibrils, which we can see in the figure below. And what it does is it creates areas that look spongy as a result. So we see all these little kind of spongy looking areas in this abnormal brain tissue, and compared to the normal brain tissue on the upper left side. Okay, Creutzfeldt-Jakob disease. So essentially this is acquired, or this is the human version of what people call mad cow's disease. The official name of mad cow disease is bovine spongiform encephalopathy. So during this uptick of bizarre deaths in the late 1990s, it was discovered that the brains of cows had these infectious material, so the encephalopathy of the brain. And what had happened is that they were actually feeding some of those organs to other cattle. Okay, so that's problem one. Problem two then is how then humans got the infection, and that was from eating